Greetings everybody. This video will hopefully explain how to calculate the center of mass of a uniform object. And again, by uniform object, we mean that the mass of the object is distributed uniformly, meaning that identical sized pieces of the object will contain the exact same amount of mass. And typically, we're going to deal with uniform objects that are regular geometric shapes: spheres, cubes, squares, cylinders, discs, rods, you know. Um, Now, in this example here, don't confuse the fact that here our grid, our coordinate grid, is in units of a centimeter. Don't confuse that with the uppercase CM. Uppercase CM means center of mass. It just happens that this coordinate system is in units of a centimeter. So don't let that throw you. The two are not, not the same. Large CM is the center of mass. So I have a uniform piece of sheet metal, and it's shaped below, and I want to calculate the x and y coordinates of the CM of the sheet metal. And I'm going to use the actual origin of the coordinate system, and I'm going to calculate the coordinates relative to the origin. Makes sense. Now notice the uniform sheet metal in the figure, it really consists of 6 identical uniform squares. And just starting at the origin, going left to right, this is square 1, oops, square 1, square 2, square 3, square 4, square 5, square 6. And they're uniform and they're identical. Each square, each of the uniform squares is 10 by 10. It's 10 centimeters by 10 centimeters, right? Nothing complicated with the figure, okay? And they're identical, so each square, they're uniform, they're each the exact same size, so they're going to have the exact same amount of mass. Well, let's call little m the mass of each square. We don't know what it is, but we don't care. It's not going to matter. Okay, now remember, for any uniform object, no matter what its shape, for any uniform object, remember when we say uniform, we mean the mass is distributed uniformly. So for any uniform object, the CM will actually be located at the geometrical center of the object. So for each of these individual squares, the individual CMs are going to be located at the center of each square, as indicated by these red dots in this figure. This is, and again, when we have 6 squares, I'm going to number them. When I do the sum from 1 to 6, I'm just going to start at the bottom, then the middle, then the top. So this is going to be 1, 2, 3, 4, 5, 6. Okay? So those red dots are the center of masses of each of the individual squares. Now when we do the sum, remember the XCM is 1 over large M times the sum of the MIXI's. Well, the X, and then likewise the YCM is 1 over big M times the sum of the MIYI's. Well, remember, so the XI's and the YI's, they're going to be the coordinates of the red dots. They're going to be the coordinates of the individual CMs of each square. So X1 is the X coordinate of square 1. X2 is the X coordinate of square 2. X3, the X coordinate of square 3. X4, the X coordinate of square 4. X5 is the X coordinate of square 5. And X6 would be the X coordinate of square 6. And those coordinates are given, and likewise for the Y. And the coordinates are given by the coordinates of the individual CMs, again indicated by the red dots in this figure. Okay, so let's look at the XCM. 1 over big M times the sum of the MIXI's. Well, remember, large M, there's 6 squares. So large M is 6 little m, right there. Because there's 6 squares. Each has a mass of m, little m. So the total mass is 6m. Nothing complicated. So 1 over m is 1 over 6m. Now in the brackets, again, I'm going to go in the order, again, from starting at the bottom, I'm just going to go left to right. This is again. And it's same for the y. This is 1, 2, 3, 4, 5, and 6. So again, x1, x coordinate of square 1, x2, x coordinate of square 2, etc. Likewise for the y's, y1 is the y coordinate of square 1, y2 is the y coordinate of square 2, etc. So let me do again. Now all the m's are the same. You know, in general it'll be m1x1 plus m2x2 plus m3x3, but m1, m2, m3, m4, m5, and m6, they're all the same. So I'm just going to call them m. See here, m, 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 and m. Okay. So now let me do x1, x2, and x3. The first three terms. Well, x1 is 5 centimeters. That's the x coordinate of square 1. Right here. What is the x coordinate of this red dot? It's 5. Because remember, these are geometric. These are uniform objects. So the CM is at the exact geometrical center of the object. So the center of mass of each square, because they're uniform, the center of mass of each square is right at the exact center of each square. So the x-coordinate of square 1 is 5. What's the x-coordinate of square 2? 15. That's 5. So this is 15. X-coordinate of the m3 or square 3 is 25. So let's see, 5, 15, 25. Okay, now let's go to 4. Square 4 or m4. But remember, the m's are all the same because the squares are identical. But for the 4 square, what's the x-coordinate? That's 5 again. See? 5 centimeters. Okay, now let's go to 5 and 6. What's the x-coordinate of 5? Square 5. 5 centimeters again. See? What's the x-coordinate of that point right there? 5 centimeters. What's the x-coordinate of square 6? 15. See? So that's in general, that's my m1x1, m2x2, m3x3, m4x4, m5x5, m6x6. But all the m's are the same. So we don't need m1, m2, m3, etc. Just call it m. Okay, so you have outside the brackets, you have 1 over 6m. And then you have here, well, the little m's cancel, because each little m in the brackets, that's going to cancel with the little m in the denominator out front. So they're gone. So then you just have 5 plus 15 plus 25 plus 5 plus 5 plus 15. That gives you 70 centimeters. So outside you have the 1/6. In the brackets you get 70 centimeters. So the XCM is 1/6 times 70 centimeters, which is 11.7 centimeters. Again, we're relative to the actual real origin. Now let's do the same thing with the y's. Remember, nothing complicated. We just now, the yi's, y1 is the y coordinate of square 1. y2 is the y coordinate of square 2. y3 is the y coordinate of square 3. y4, y coordinate of square 4. y5, coordinate of square 5. y6, y coordinate of square 6. Nothing complicated. Okay, and again, 1 over large M, that doesn't change. The total mass is still 6m. Now notice, again, remember the squares are, I'm just starting at the bottom and going 1, and then again, nothing complicated, same as the x. This is 1, 2, 3, 4, 5, and 6. So what's the y coordinate? So notice the y coordinate of squares 1, 2, and 3. The y coordinate of each one is 5 centimeters. So see right here, 5, 5, and 5. Okay, so that takes care of squares 1 through. Now what about square 4? What's the y coordinate of square 4? 15. See that? 15. Okay. What's the y coordinate of square 5 and square 6? Well, the y coordinate of 5 and 6, the y coordinate of each one is 25. 25, 25. All right. Then again, the m's cancel. Each m, the m outside in the denominator cancels with the m's inside the bracket, so they go away. So you have 1/6, and then you have 5 plus 5 plus 5 plus 15 plus 25 plus 25. That gives you 80 centimeters. So you have 1/6 times 80 centimeters, and that's 13.3. So the x and y coordinates of the center of mass are respectively 11.7 centimeters and 13.3 centimeters. And there's a problem very, very similar to this on exam 3, and I'll post another video because I have a hint for that problem, and I'll post another video, but very straightforward. Again, we're dealing with uniform objects, and so the CM of and this sheet metal, it consists of 6 identical squares, uniform identical squares, and so the CM of each square is indicated by those red dots. And when we talk about the XI's and the YI's, they're the coordinates of the individual CMs of these red dots. And that's it. And so that's the answer. And let me get this video posted, and that's it.